Cybersecurity is one of the fastest growing and most respected fields today, and earning your CISSP certification can open the door to some of the highest paying and most trusted roles in the industry. But passing the CISSP isn't just about memorizing facts, it's about understanding how to think like a security leader. That's exactly what this course is designed to do. I will walk you through every domain, simplify complex topics, and share real-world examples that will help you not only pass the exam but truly master cybersecurity. So before we begin, like this video, hit that subscribe button and turn on the notification bell. Welcome to the domain 4 of our CISSP course, Communication and Network Security, and this domain also carries a weightage of 13%. So this domain is, and you can say, carries a significant weightage in overall exam content. So this domain is, you can say, a little bit difficult for most of the folks due to the networking concepts because they are a little bit more technical. But the good news here is that I myself have a very strong background in computer networks and security, about 15 or 16 years. And my main experience is in configuration, design, and troubleshooting of computer networks, including switches, routers, and firewalls. So I have a very good concept in this domain, and I hope that after going through this video, you people will have a good understanding and a good preparation for the CISSP exam. So let's get started. So secure network architecture overview. So a strong understanding of networking principle is essential for building and managing secure network architecture. We are talking about the basic networking principles and basic networking concepts. So understanding these basic concepts is essential for you to manage and secure network architecture. So first of all, we will briefly go through the different types of networks. And these networks include the very popular and the most common one is the LAN, local area network, which connects devices within a limited area, you can say in a building, inside your home, in an office building. And you all are, I hope, familiar with the type of cable that is mostly used in LAN, that is Cat6. Previously, it was Cat5, now Cat6, and most latest model is a Cat7. So this is the cable that is used inside the LAN, and it has a maximum distance of up to 100 meter. It works up to 100 meter, and if we want to go beyond 100 meter, we can either use the optical fiber or we can deploy a switch, a networking switch, and then re-extend the network beyond 100 meter. Next is the MAN. So MAN is larger than LAN. It is metropolitan area network, and it connects multiple LANs across a city. So now we are going from a single office or an organization to a complete city. And an example of a MAN is a citywide Wi-Fi. It can also be a wired network, so sometimes known as a Metro Ethernet or ME network, which is connects different organization or different offices in a city through OFC network. So this is also an example of MAN. Next is the largest network, and that is the WAN, wide area network, which covers large geographical areas, such as it connects cities or even countries. And the most popular example and the largest WAN is the internet. WAN is the, you can say, the smallest network type, and it is personal area network which connect devices in a very close range, such as 10 yards. And one example of WAN is the Bluetooth. So internet, as we studied, it is the global WAN connecting systems worldwide, and it is the public web, such as you people now are watching this video on the internet. You are connected from all over the world watching this video. Intranet is an internal organization network which is within a specific organization. As the name indicates, it is intra. So inter is large concept between countries and all over the world. Intra is within intra or within an organization such as a company internal network or portal. Extranet is shared network between an organization and external partners such as vendor and customer access portal. Now coming over to OSI and TCP IP models overview. So the purpose of networking model, why we have developed these models, it is to define standards for network communication and interoperability between different protocol, different devices and different vendors application. And it uses a layered approach to simplify design and enhance security, as we will study different layers in OSI model in a couple of moments. It enables interoperability among vendors and systems, support modular engineering, troubleshooting, and product development. And models are basically guidelines, not strict requirements. So now coming over to an overview of OSI and TCP IP model. So OSI reference model, that is ISO, it is defined in the ISO 7498-1 and it has 7 layers. So we were starting from the topmost layer, that is layer 7, and it is the application layer. And its function is that it use the interface for user applications, ensure readable data exchange, and the data unit or protocol data unit that is used at this layer is known as simply as data. Now, examples of protocols used at this layer are popular protocol HTTP, secure version of HTTPS, file transfer protocol, simple mail transfer protocol, and other multiple protocols. Next layer, layer 6, is the presentation layer where data formatting, encryption, and compression takes place. Again, the PDU at this layer is known as data. And example of protocol at this layer are TLS, transport layer security, secure circuit layer, and MIME. Layer 5 is the session layer, which manages and maintains communication sessions, and PDU again is known as data at this layer. An example of protocol at this layer includes RPC, remote procedure call, SMB, and NFS. And SMB is file transfer, is SMB stands for server message block, and NFS is again file system, network file system. Layer 4 is the popular transport layer, and its function is reliable delivery of data, flow control, and error checking. And PDU or data unit at this layer is known as segment, and popular protocol at this layer are TCP, transmission control protocol, and UDP, user datagram protocol or unit datagram protocol, if I am correct. So layer 3 is the network layer, and here the logical addressing and routing takes place. Logical addressing takes place through IP addresses. And the PDU at this layer is known as packet, and popular protocol at this layer are IP, ICMP, OSPF, and IPSec. So OSPF is the dynamic routing protocol. ICMP, you all people must know, it is used for troubleshooting of networks such as ping. IP is the popular protocol which is used for logical addressing routing, and IPSec is used as a security on this layer, also known as IP security. Layer 2 is the data link layer, which does the physical addressing, and physical addressing is done through MAC, logical through IP address, physical through MAC, and frame transmission takes place at this layer. So the PDU at this layer is known as frame. And examples of protocol at this concept and protocol at this layer are Ethernet, VLAN function at this layer, and frame relay also takes place at this. And the layer number 1 is known as the physical layer, which is where the transmission of raw bits via cable or through wireless media takes place, and the PDU at this layer is known bits and bytes. And examples of protocol at this layer are USB, Bluetooth, and 10 base. So what is the difference or the comparison between the OSI model and TCP/IP model? So OSI model is a conceptual framework describing how data moves through a network of 7 layers. TCP/IP model is the practical suite of communication protocol used on the internet. So this is a conceptual model, OSI model. It was developed, but it was not practically used. The practically used model is the TCP/IP model, which has less layer than 7. We will study in a while that how many layers has TCP/IP model. So the general rule is that layer, when we talk about layers, we are talking about the OSI model layers, and when we talk about protocol, we mainly refer to the TCP/IP model. So these are the layers of the TCP/IP model. In OSI model, we have 7 layers, and in TCP/IP model, we have 4 layers, and these layers are application layer at the top, then transport, internet, and network. The application layer is now layer 4. It handles high-level protocols like HTTP, FTP, SMTP, and DNS. Number 2 is the transport layer, which is layer 3. Here it is layer 3, and it manages end-to-end communication. And as we studied, the popular protocol at this layer are TCP for reliability and UDP for speed, where data transmission is needed in speed, but reliability is not as essential as speed of transmission. At layer 2, we have the internet layer, which handles addressing, as we studied logical addressing through IP addressing, routing, and packet forwarding, which takes place through IP, and for troubleshooting or error checking, we have ICMP. And the layer number 1 is the network access layer, which defines physical transmission through Ethernet, Wi-Fi, address resolution protocol, and MAC addressing. So now coming over to a comparison of the TCP/IP and OSI model. So as we can see in this diagram, the upper 3 layer of OSI, they combine and make the application layer in TCP/IP. The transport layer similarly corresponds to the transport layer in both these models, network layer to network layer, and the you can say the first 2 layers, the layer 1 and layer 2 in OSI model, basically corresponds to the network access layer. So the similarities between these two are that both are layered model for network communication. Both use encapsulation and de-encapsulation. So when data moves, let's suppose downwards from application to transport, data is encapsulated. And when it moves then upward, let's suppose it is received at the opposite side, and upside data is then de-encapsulated. So this is what we mean by encapsulation, de-encapsulation. Encapsulation means that at each layer adds its own header. For example, at transport layer, the port numbers are added. At network layer, IP addresses are added. At data link, MAC addresses, and so on. The difference is that TCP/IP has 4 layers, while OSI has 7 layers. TCP/IP is more practical, rather it is practically used, and it is the only model that is widely used, while OSI is theoretical. TCP/IP combines the presentation and session layers into the application layer, as well as the application layer. So again, now coming over to each layer of the TCP/IP and their corresponding attacks that takes place at each layer. So as we studied, the layer 1 is the physical layer, which handles transmission and reception of raw data across a medium. It converts digital bits into electrical, optical, or radio signals. And so why these 3 different types of signal? Because if the communication is taking place in a lane through Cat6. Let's suppose if the media is Cat6 or copper cable, the bits are converted into you can say electrical signals. If it is, if, you can say the cable is OFC, it is converted into optical signal, and if it is wireless, it is connected into radio signal. So it defines network topology such as ring, bus, star, and mesh. And examples of physical layer concepts include the Ethernet cables, Bluetooth, Wi-Fi, and USB. What are some attacks that takes place at layer 1? The first one is the sniffing, which is capturing the signals or cables or wireless traffic. For example, if you are simply listening to the Wi-Fi or wireless traffic, you are capturing the medium traffic through sniffing, and this takes place at layer 1. Interference, so introducing noise to disrupt communication. So for example, if the Wi-Fi is working at 2.4 gigahertz, you introduce signals in this particular spectrum, the interference will be introduced into Wi-Fi signal, and traffic or the signals will be weakened and speed will be low, and overall efficiency of network will be disrupted. Cable damage, so physically cutting or disconnecting cables, and similarly denial of service by jamming or overloading physical channel. So physical channel may be the, as we said, the Wi-Fi channel. You can someone can jam them, or they can also jam the physical cables by cutting them or by overloading them through other means. Again, layer 2 is the data link layer, where transfer of data takes place between nodes over the physical link. It converts bits into frames for reliable node-to-node communication. It provides error detection, synchronization, alerts, and flow control. And it defines how devices connect, such as bus, ring, topology, etc. And switches. So the switches, which are the network devices, they basically operate at this layer or layer 2. So the MAC address is the concept that work at this layer. It uses 48-bit hexadecimal identifier for each device. So the format of the MAC address is this one or this one. Some vendor or some time it is these, you can say, hexadecimal number are separated through colon and somewhere through dashes. So the first prefix of 48 bits is basically the manufacturer ID, which is assigned by the IEEE. We are talking about these first 24 bits. So the each octet is 8 bit. So 8, 8 and 8, 3 into 8, 24. And the suffix, that is the last 24 bits, these S stands for suffix. These are the device serial number, and these uniquely identify each device. So each laptop, each PC, each you can say router, which they have unique serial number known as the MAC address, and it is identified by this. So let's suppose if we have Cisco networking devices, they all will have the same first 24 bits, these that will identify the device as the Cisco, while the last 3 octet they will vary, will be unique identifier for each device. For example, this is a MAC address, so it is the belongs to link system, and this can be identified through these first 24 bits. Layer 2 attacks are MAC spoofing and ARP poisoning. So in these attacks, attackers forge ARP requests and replies to impersonate as another device, and they redirect traffic to attacker's system, and this type of attacks enables man-in-the-middle attack and session hijacking. Layer 3 is the network layer, which provides routing and forwarding. So packets travel from source to destination. So it receives service requests from transport, that is layer 4, and issues requests to Layer 2, that is data link. And the function of network, as we already studied, these are logical addressing through IP addresses, routing, packet fragmentation, reassembly, forwarding, and delivery error reporting. And it supports connection oriented and connectionless protocol. So it supports both type of protocol. The important concepts in layer 3 network layer are logical addressing, or basically the IP addresses, which is the host logical address, host logical location. For example, 192.168.1.100. This may be an address of a host, and it shows that this host is located at this logical location. Gateway routers forward packets between segmented networks. That is, the gateway or router basically transfer traffic from the intranet from internal company network to the outer net, that is internet. So fragmentation means splitting large packets into allowable sizes without losing integrity. And IPSec is a set of protocol for securing IP traffic through VPNs and encryption. Common network layer protocols includes the IP protocol, which is used for addressing and routing, and we have two versions of this, IPv4 and IPv6. BGP is the border gateway protocol, which is a path vector routing between autonomous systems. EGP, we have two types of BGP. One is eBGP, which is between autonomous systems, and iBGP, which is within an autonomous system. So E, you can say, it stands for external, and I is for internal. So iBGP works within an autonomous system, which you can say is managed or controlled by same organization. So uses ASNs, keeps multiple paths in RIB, and chooses path minimizing autonomous system hubs. OSPF is another dynamic routing protocol. OSPF is Open Shortest Path First. It is a link state interior gateway protocol for fast convergence and scalability, and it builds topology and recomputes routes quickly. And we have the it works at IPv4, uses IPv4 and IPv6 in OSPF v version 3. So it encapsulates directly in IP protocol. It is encapsulated directly in IP, and it is known as protocol 89 inside the IP. You can say header. So RIP is another dynamic routing protocol. It stands for Routing Information Protocol. It is a distance vector, and it uses hop count. It works up to maximum 15 hops. It is simple and suitable for small networks, and it implements split horizon route poisoning, hold down timers, and uses UTP port 520 for operation. So RIP-NG uses port 521 for IPv6. RIP-NG, it is the latest or next generation RIP, which uses port 521 on IPv6. So common network layer protocol, again, another one is ICMP, Internet Control Message Protocol, which is used for troubleshooting and error messages such as ping and trace route. And common message types are echo request, reply, destination unreachable, time exceeded, and direct. Another network layer protocol is IGMP, which is Internet Group Management Protocol, and manages IPv4 multicast group membership is one to many. And IPv6 basically uses MLD, which is part of ICMP version 6. Now coming over to some layer 3 attack vectors. The first one is IP spoofing and address forgery. So attackers forges source IP addresses to distinguish origin or redirect traffic. Next is the man in the middle attack. which is via route manipulation or malicious routing updates. Then we have the denial of service and distributed denial of service attack, which is overwhelming the network resources to deny service to legitimate users. Then we have routing protocol attacks, for example, BGP hijacks, falsified route advertisement, or OSPF link state manipulation. And lastly, we have reconnaissance using ICMP ping and traceroute to map networks for later attacks. Next, we have the layer 4 transport layer, and its purpose and key function include that it provides end-to-end communication and reliable data transport between hosts. It shields upper layers, that is layer 5 to 7, from lower layer complexity. It manages segmentation, flow control, multiplexing, error detection, and recovery. It establishes and maintains and terminates virtual circuits for data transmission. Core functions again include flow control, which prevents sender from overwhelming the receiver. Multiplexing is that it allows multiple applications to share the same physical link. Virtual circuit is logical connections for managing sessions between hosts. And error checking and recovery basically detects transmission errors and retransmits lost data. The key protocol at this layer, layer 4, are transmission control protocol TCP, which is a connection-oriented protocol. It ensures reliable delivery through sequencing and acknowledgements. It uses three-way handshake to establish connection, and the three-way handshake is first packet is SYN, then we have SYNAC, and third is ACK. So it guarantees delivery, detects errors, and retransmits lost packets. It is slower due to overhead but ensures accuracy. It is used by protocols such as HTTP, HTTPS, FTP, SSH, and SMTP. So socket is a concept which is the combination of IP address and port. For example, the IP address 192.168.100.10 column 22. This is known as socket. So this is how the three-way handshake takes place. So the client first sends the SYN packet, the server responds with a SYNAC packet, and lastly, the client responds with ACK packets, and this way, three-way handshake is established. The next popular protocol at this layer is User Datagram Protocol, or UDP. So it is connectionless, lightweight, and fast, which is best effort delivery. So this protocol gives no sequencing, flow control, or retransmission as opposed to TCP. So it is ideal for real-time data where speed is greatly required than reliability. And it is used by DNS, DHCP, SNMP, voice over IP, and video audio streaming, as well as the Internet of Things devices. So datagram is the basic data unit in this connectionless transmission. So some layer 4 attack vectors include the SYN flood attack, which is the denial of service attack, where the target is flooded with incomplete TCP handshakes, which exhaust the resources of the target or the server. Port-based attacks are Trojan and malware that exploits open TCP and UDP ports. And session hijacking is where attacker intercepts or takes over active TCP sessions. So this is how the you can say the SYN flood attacks, or you can say ACK flood attacks or denial of service attack takes place. So we have the server. This is the attacker which overwhelms the server with these forged ACK packets. And when the legitimate user tries to connect with the server, its connection or request is denied because the server is already very busy or overwhelmed by these packets. Layer 5, that is session layer. So the purpose and responsibility of this layer are that it manages logical and persistent connections, that is session applications or different hosts. It establishes, coordinates, and terminates dialogues between local and remote applications. It facilitates higher level interactions, for example, RPCs, so application processes can request, receive services across the network. The modes of operation on session layer are full duplex, which is a two-way simultaneous communication. So both the endpoints send and receive data at the same time or at once. Half duplex is two-way, but only one direction at a time takes place. So only one device sends the data, the next receives it, and then the other one sends the data and second device receives it. So at a time, only one can send. Both devices cannot send the data at the same time. Simplex is the one-way communication where only sender sends the data and receiver only, such as you can say your television, your TV when connected to cable network is simplex because it only receives signals and displays it. It does not send something back. So layer 5 attack vectors include session authentication compromise. So in this attack, attackers break session setup or authentication and impersonates a participant. So weak cryptographic sessions, so deprecated or weak SSL TLS versions allow session hijacks or downgrade attacks. Protocol specific exploits, so vulnerabilities NetBIOS, NFS, or other session implementation, such as denial of service and privilege escalation. Session hijacking and replay also takes place at layer 5, which is stealing and reusing session tokens to impersonate an active user. Layer 6 is the presentation layer, so where which translates here translation takes place between lower layer and the application layer. It handles data formatting, compression, and encryption, and ensures compatibility between different systems. Key functions include that it converts data into application readable formats. It uses standard data formats such as for image, audio, and video. So it applies compression, for example, JPEG and PEG, and it performs encryption and decryption, for example, SSL and through TLS. So encryption notes is that encryption and decryption may occur at multiple layers. SSL generally operates at the presentation layer, while TLS shares functionality with the session and presentation layers. So layer 6 attack vectors include target encryption and decryption mechanisms, exploit weaknesses in cryptographic algorithms, use cryptanalytic techniques to break encryption, and attack poorly implemented or outdated cryptography. Layer 7 or last layer is the application layer which is the highest layer of the OSI model and closest to the end user. It provides network access for software applications and acts as an interface between the user and the network and facilitates communication between applications across the network. Key functions include that this layer identifies communication partner, it determines resource availability, synchronizes communication sessions, and it supports protocols such as HTTP, FTP, SMTP, Telnet, and SNMP. It enables applications like web browsers such as Chrome, Safari, Firefox to function. So layer 7 attack vectors are exploitation of application layer protocol weaknesses such as HTTP, FTP, SMTP, and SNMP. Web-based attacks take place at this layer such as HTTP flooding, input validation attacks, SQL injection, and cross-site scripting. User interface attacks basically targets end user interactions. Authentication weaknesses such as weak as reuse passwords, poor password management practices also takes place at this layer. Now coming over to our next topic, which is IP addressing or internet protocol networking. So IP is the core protocol of the internet and it operates at network layer in OSI model and internet layer at TCP IP model, and it enables data transmission across network boundaries. It has two main versions, IPv4, IPv6. IPv6 is the latest and it is gradually replaces the older IPv4. So now coming over to Internet Protocol version 4, that is IPv4, it uses 32-bit IP addresses. An example of this is 172.8.3. So each of these octet is 8-bit. So 8, we have 4 octet. So 8 into 4 is equal to 32. So it is 32-bit. And addresses are written as 4 decimal octet, and these octet ranges from 0 to 255. So if you see something like this 299.1Z, so this address is wrong. For this octet range is up to 255 from 0 to 255. So the IP addresses are divided into classes. So we have class A, B, C, which are for general use, used by the networks and given to host. Class D is for multicasting, and class E is for experimental use. So IPv4 provides approximately 4 billion unique IP addresses. So originally, when internet was new, devices were very few, it was sufficient. But now these addresses are limited due to the growth of internet and internet of things devices and other connected devices. So these are the classes of IPv4. We have class A. So the first octet, as we saw in the previous example, it ranges from 1 up to 126. So when you see any IP address such as 10.10, if the first octet is from 1 to 126, it means it is class A. So this address is class A because the first octet is 10. Maximum number of hosts per network are this 16,777,214. There are huge number of hosts in a single network, and we have a total number of 1 to 8 networks. Class B is the first octet in this class ranges from 1 to 8, from 1 to 8 to up to 191. So if you see an IP address of, well, let's suppose 135.10.100.1, then it means this address belongs to class B. And we have 65,535 number of hosts in class B network, and we have 16,384 number of networks in this class. Then we have class C, and class C first octet ranges from 192 up to 223. So the popular IP addresses such as 192.168 and 1.100, this belongs to class C. So it has the maximum number of hosts of 254 in this class, and we have these number of networks at class C. Class D has the first octet range of 224 up to 239, and since this is used for multicasting, so we don't have number of hosts per network. Similarly, this is number of network is also not applicable. And this class E first octet range is from 240 up to 255. So this is again reserved IP range. So if you see something IP address starting from, let's suppose, 245, it belongs to class E and experimental. So let me clean the screen. So transition from IPv6 from IPv4 to IPv6. So IPv6 is the long-term solution for IP address exhaustion. Network address translation, or NAT, basically currently extends IPv4 usability. how does this extend IPv4 visibility in this matter? So these are the private IP addresses that are used inside, you can say, LAN or your local private network. And then all these devices can talk to the internet or external network or a single IP address through a process known as NAT or network address translation. So each of these devices, when they want to talk to external world or internet, this a single IP address is used by all these devices, and this is IP addresses are translated by the NAT server. So you can say now that all these addresses can now be used by anyone else where may have another company. Let's suppose this is company A, company B. So this company can again use all these addresses, and then they will have their own unique public IP address to which all these devices will talk to the internet. So in this way, we can reuse the private IP addresses through netting. So it translates the local IP address to the global or public IP address. It operates at the network layer or layer 3. It is implemented inside firewalls, routers, and gateways and proxies. So originally it was designed to extend IPv4 address usage, but now it is considered a legacy technology with both pros and cons. Pros is that again it makes your these internal devices invisible. Only your public IP address is visible. Cons is that it interferes with some type of traffics, and it is, you can say, difficult to troubleshoot and to implement as well. So advantages of NET are that it connects a private network to the internet using a single or few public IP addresses. It uses private ranges which are defined in RFC 1918, and these ranges are 10, if I write them particularly, 10.0.0/8, 172.16 slash 12, and 192.168 slash 16. So it hides the internal IP structure and network topography, as I said. It prevents direct access from the internet to your internal devices. It allows outbound connection from private network and ensures return traffic. It enhances security by obscuring internal IPs from the attackers. And it is cost effective because it conserves limited public IPv4 addresses. Disadvantages of network address translation include that it is a temporary solution and lacks an official IETF standard. It is inconsistent implementation across devices. So it is implemented in multiple ways across different devices. It breaks peer-to-peer communication, and so workarounds are done to tackle this issue. For example, Skype uses supernodes to bypass net or network address translation issues, and conflicts with IPSec integrity checks, packets hash mismatch. It is solved using the NetT or net traversal, and it is unnecessary for IPv6, which provides a vastly large address space, so it is no longer used in IPv6. So key takeaways are that NET played a vital role prolonging IPv4 usability, enhancing network privacy, but with the adoption of IPv6, its necessity is diminishing. Now coming over to our next IP protocol, which is IP protocol version 6 or IPv6. So this previous one, IPv4, used 32-bit. It uses 1 to 8-bit IP addresses. It is written in hexadecimal format separated by columns. So IPv4 was used in decimal. This one is written in hexadecimal format, such as this one. It is divided in two parts. 64-bit is the network prefix and 64-bit is interface identifier. So both these make the 1 to 8-bit IP address. It supports 1028 times more addresses than IPv4, so it supports way more addresses as compared to IPv4. So it enhances addressing, routing, and scalability. The benefits of IPv6 are that it has scoped addresses, that it adds security and access control built in. It enables admins to group, allow, or deny access to services. It has the auto configuration features, which eliminates the need for DHCP and NAT, and each device can self-assign a public IP address. Quality of service, it includes priority values for efficient traffic management. It has a massive address space, which ensures future expansion of connected devices. So adoption and challenges of IPv6. So it was created by the IETF to solve the IPv4 address exhaustion. It is supported by most modern operating systems since 2000. Its adoption remains slow due to upgrade cost of IPv6 capable devices, satisfactory performance of existing IPv4, limited immediate return on investment for many organizations. So early adopters are large enterprises, research labs, and universities. So now coming over to network attacks. So many networking protocols were developed before security was a priority. So as a result, vulnerabilities still exist in network system host. Even hardened system can be attacked through network services. Security in networking was often an afterthought, though modern revision aim to improve it. Understanding network vulnerability. So network protocol define how hosts communicate across different layers. Each OSI layer can be targeted by specific attack vectors. The knowledge of these layers helps security professionals identify and defend against attacks. So now coming out to different attacks, and first one is the distributed denial of service attack. So DDoS is flooding a target system with excessive traffic to make it unavailable for the legitimate users. So attackers basically use these brute force traffic floods, for example, UDP packets, send floods, as we studied in our previous slides, from multiple sources. And commonly, these type of attacks are launched through infected Internet of Things devices and compromised machines, also known as zombies, or sometimes botnets. The mechanism is that a botnet or network of hijacked systems sends massive simultaneous requests. Each device contributes minimal traffic but collectively overwhelms the target. The goal is to consume bandwidth or server resources, causing system failure. So SYN flooding attack, which takes a transport layer fall, which is a type of the DOS or denial of service attack. So this is how it works. It exploits the TCP three-way handshake. Attackers send a flood of SYN packets but never complete the handshake with acknowledgement. Victim system keeps half open connection which exhausts the system resources. This type of attack is also known as half open attack. The impact is that the server becomes unresponsive to legitimate users. It is common even today, despite existing applications. The mitigation technique include to increase the backlog queue, so allows more half-open connections, which requires more memory and may impact performance. To recycle oldest half-open connections, so uses a first in, first out, that is FIFO strategy, to override the oldest request and helps maintain service availability for legitimate users. Next is the man in the middle attacks, which which are the attacks in which attackers intercept, relays, and possibly alters communication between two parties. Sender and receiver believe they have a direct and private connection, although there is someone in between them. Types of an example of man-in-the-middle attack include eavesdropping, where attacker passively listens while relaying messages. Impersonation is where attacker circumvents authentication and presents as a legitimate endpoint. Packet sniffing or passive man-in-the-middle attack captures unencrypted traffic to harvest credentials, IP addresses, and data. And hijacking or active man-in-the-middle attack is where attackers steal or inject session tokens, cookies, to assume a user's session. So how does the man-in-the-middle attacks work? So attackers position between endpoints, that is network sniffing, or spoofing, or installing rogue access point or proxy. The attacker then intercepts packets, optionally modifies payload, and forwards them to the destination. The victim remains unaware unless authentication or temper checks fail. Detection or indicators of these attacks are unexpected latency or response time anomalies versus the baseline, TLS or HTTPS warning or certificate mismatches in browser, and unusual session behavior such as duplicate session or sudden session termination. Prevention and mitigation of man-in-the-middle attacks include strong authentication, which include mutual TLS and X.509 certificates issued by trusted certification authorities, encryption end-to-end, post TLS and HTTPS and modern cipher suits, disable the deprecated SSL, certificate pinning and HSTS, which reduce risk of forged certificates and downgrade attacks, temper detection, so monitor latency, integrity checks, and message hashes, network control, so disable promiscuous ports, use secure Wi-Fi protocol, which is WPA2 and 3, and isolate untrusted networks. Monitor and alerting, so detect unusual session patterns, repeated authorization or authentic failures or certificate anomalies. So our next attack type is packet sniffing. So there is a legitimate use of packet sniffing in network troubleshooting, performance monitoring, and protocol analysis, such as an example of a tool that can be used for network troubleshooting using packet sniffing is Wireshark, which captures packets on a live wire and then it can be used for network troubleshooting. On the other hand, the malicious use of packet sniffing is when passive capture of clear text credential, tokens, payment data, and configuration info is done with the intent of using this info maliciously. Reconnaissance to identify deprecated ciphers, Active Directory servers, or exploitable services. The mitigation of packet sniffing include encrypting the sensitive traffic through TLS, SSH, and IPSec to limit the administrative access to network taps and monitoring tools. Network taps means to capture network data through network taps. Taps is, for example, if we have this network switch and we are having all type of data coming and going through different ports where different clients are connected. If we take one port, use this as a tap, and we configure this network device, this switch or router, such that all the in-out data is copied to this port. So all the data can then be analyzed on this port, and this capture is known as network tap. Use port security 802.1x. This is in fact the port security and network segmentation. Next is the hijacking attacks. So in hijacking attacks, attackers exploit active sessions by stealing or forging session identifiers such as cookies and tokens, and they can run parallel sessions or terminate the victim's session. So common vectors in hijacking attacks include sniffed session cookies or unencrypted channels, cross-site scripting to exfiltrate tokens, and session fixation or replay attacks. Mitigation include using secure HTTP only same-site cookie flags and short session lifetimes, enforce HTTPS only cookies and token binding where possible, and implementing multi-factor or MFA authentication and anomaly-based session monitoring. Our next topic is MITRE attack framework. So MITRE framework was developed by MITRE organization, which is a US non-profit research organization. And the purpose of this framework was to provide a comprehensive knowledge base of real-world adversary tactics and techniques. It focuses on how the attackers operate, the attacker's behavior, goals, and attack steps, and it is used by security professionals to develop threat models, analyze incidents, and improve defenses. So it is organized by tactics, that is the attacker attacks goal, and techniques, the methods used to achieve those goals. And it is a global resource and freely accessible at this address site. So it is used for threat detection, red teaming, incident response, and security assessment. So now coming over to some secure protocols that are secure by nature and that can be used inside your organization and should be used in fact. So the purpose of secure protocol is to provide secure communication and authentication over networks. Some common secure protocols include SSH, TLS, Kerberos, IPSec, and IKE. We will study these in upcoming slides. First one is the SSH. So SSH replaces the insecure Telnet protocol. Telnet used clear text data when communicating with the remote server. SSH uses encrypted data. So function is that it enables secure encrypted communication over TCP. It is based on client-server model for remote login and command executions. So it prevents session hijacking, eavesdropping, and man-in-the-middle attack because the session is encrypted. Versions are SSH1, which is outdated and insecure and should not be used. SSH2 has improved security and efficiency against spoofing and man-in-the-middle attacks. The use cases include securely managed servers, network devices, and file transfer through SCP and SFTP. So both of these also use SSH. Next secure protocol is the transport layer security TLS. So the purpose of TLS is to provide secure web communication. TLS has replaced the SSL, which was the main protocol for secure web traffic. Now TLS is the main protocol. So SSL is legacy session-oriented protocol, which was once used for web, email, FTP, and telnet. And SSL status is deprecated due to known vulnerabilities. So now we should use TLS instead. So TLS improvements include stronger authentication and encryption. It prevents tampering, spoofing, and eavesdropping. Another secure, rather the TLS features include that it supports secure client-server communication or insecure networks. It enables one-way authentication via digital certificates. It also enables two-way authentication using mutual certificate exchange. Two-way means authentication of both the client as well as the server. It operates typically as the initial TCP payload, securing higher layer protocols. It can also operate at network layer or layer 3 as OpenVPN. It supports encryption for both UDP and SIP connection. SIP is the session initiating protocol, and it is the primary mechanism for secure e-commerce sessions. The key advantage of TLS is that no VPN client is required. When we use the browser for secure browsing, we are using TLS and we don't use any VPN client. So TLS can create on-demand encrypted tunnels via the web browser for remote access without the need of any client. Next is, so again, this is the same slide. So our next secure protocol is the Internet Protocol Security IPSec. So the purpose of IPSec is to provide confidentiality, integrity, and authentication for IP network data. It secures communication between systems by encrypting and authenticating IP packets. So IPsec security services include authentication header known as AH, which authenticates the sender of the data and it detects data modification during transmission. So it is used for, you can say, authentication as well as integrity. As the name indicates, this protocol mainly gives us the authentication and integrity of data. On the other hand, encapsulation security payload, it authenticates the sender as well as it encrypts the data for confidentiality. So this is the main difference between these two protocols. ESP basically provides the confidentiality as well as authentication, while the AH does not provide confidentiality, it only provides integrity and authentication. Security aspirations are the bundles of shared key and parameter which are required for authentication header and our encapsulation security payload protocol. It defines how two systems will secure the traffic. So IPsec has two modes. First one is the transport mode, which encrypts and authenticates only the IP payload, or you can say the data portion without the header. It is used for end-to-end secure communication. The second mode is the tunnel mode, which encrypts and authenticates the entire IP packet, that is header as well as data. It encapsulates it in a new IP packet. So internal mode, the IPsec encapsulate the whole IP packet inside a new IP packet or new IP header. It is commonly used for VPN between networks or gateways. Gateway means that this one is used for VPN between, you can say, firewall to firewall, while this one can be used, you can say, from client to server. So another important concept in IPsec is the Internet Key Exchange or IKE, which is used inside IPsec. And the purpose of IKE is to establish a secure authenticated channel between two entities for IPsec. It uses the X.509 PKI certificates for authentication and Diffie-Hellman-Merkle key exchange for shared secret creation. Versions of IKE include IKE version 1, which was the original version and less secure. IKE version 2 is the enhanced version addressing configuration and security flaws. Vulnerabilities of IPsec or IKE, you can say, offline dictionary attack. So to avoid this attack, you need to use strong and high entropy passwords. Downgrade attacks forcing IKE version 1 from IKE version 2. So segment system using IKE 1 and IKE 2 to prevent mixing. Virtual local area network or VLAN. So the purpose of VLAN is that VLAN isolates network traffic into separate broadcast domains. It uses IEEE 802.1q tagging to assign VLAN IDs to Ethernet frames, and the access ports in VLANs you carries untagged traffic and belongs to a single VLAN, while the trunk ports carries tagged traffic and it can be used to carry multiple VLANs traffic. So native VLAN is the untagged VLAN on trunk port. avoid, so you should avoid using the VLAN 1 as the native VLAN. The benefits of VLAN are that it reduces broadcast traffic, it improves security and segmentation, and enhances network manageability and performance. Some common VLAN attacks and mitigation. First one is the VLAN hopping, also known as double tagging. So attacker adds two VLAN tags. First switch removes the outer tag. Second switch forwards frame using the inner tag, and attacker gains access to the target VLAN. Mitigation of this attack includes double auto trunking or DTP. Change native VLAN to an unused one, not the VLAN ID 1. As we studied, we should not use VLAN ID 1 for native VLAN. Configure all ports as access ports unless trunking is required. Disable unused ports and assign to an unused VLAN. Use port security 802.1x authentication and VLAN access control list. Avoid default VLAN 1 and limit trunk ports. Secure management access with SSH and logging. So our next topic is SCADA, and SCADA is supervisory control and data acquisition. So it is an architecture that uses computers to monitor and control industrial processes. So industries using SCADA include power generation and transmission, oil and gas pipelines, water and waste water management, manufacturing, and utility. These are some of the industries that use SCADA systems. So the protocol used by SCADA is DNP3 or Distributed Network Protocol 3. So DNP3 or Distributed Network Protocol 3 is a legacy open standard protocol used in utility industries. It enables data transfer and control commands and can be encapsulated over TCP/IP for connectivity. What are some SCADA security risks and mitigations? So security risks inside SCADA include encapsulation for DNP3 or TCP/IP. So this increases exposure to network-based attacks. So if you use TCP/IP, you are exposed to the vulnerabilities and attacks that are specifically used against TCP/IP stacks. When in the middle, attacks can intercept and alter control signals. Weak or no encryption AC designs. Integration with office network and internet increases the vulnerability and exposure. Target for nation state or critical infrastructure attacks. What are some mitigation strategy against SCADA security risks? So these include network segmentation, always isolate SCADA from corporate and internet networks, implement firewall and intrusion detection and prevention system for SCADA traffic, use VPN and strong encryption for remote access, apply strict access controls and authentication, regular patching and firmware updates, continuous monitoring for abnormal activity. So what are converged protocols? So converged protocol basically merges specialty or proprietary protocol with standard protocol, for example TCP IP. This reduces reliance on costly proprietary hardware and enhances performance depending on protocol type. So the purpose of converged protocol is that they enable integration of data, storage, and voice over a single network infrastructure. So now coming over to some common converged protocol, and the first one is fiber channel over Ethernet or FCOE. So this combines fiber channel with Ethernet using Ethernet frame. It supports SAN and NAS storage up to 256 gigabit per second and works over copper or fiber cable. So SAN is storage area network and NAS is network attached storage. Key benefits of FCOE include that it reduces cost by using Ethernet instead of dedicated fiber network. It enables high-speed data storage. Next is the Internet Small Computer System Interface or ISCSI. So it transmits SCSI or SCSI commands over IP networks and acts as a virtual SATA or SCSI cable for remote storage. Benefit is that it is low cost alternative to fiber channel and supports remote storage access over standard IP. Next is the multi-protocol label switching or MPLS. So this routes data using short labels instead of IP addresses, operates between OSI layer 2 and 3. It gives us faster data transfer, supports multiple network types such as ATM, DSL, and SONET. Last one is the voice over IP or voice over internet protocol. So this encapsulates voice and multimedia communication over IP network. It is cost-effective telephony, integrates easily with existing data network. For example, when you are calling someone over your WhatsApp or when we were using Skype, so these all are examples of VoIP. An important topic is micro-segmentation. So micro-segmentation basically divides a network into smaller and isolated zones to protect resources individually. This requires re-authentication when accessing resources across zones and enable policies that limit traffic between segments and supports zero trust architecture principle. Benefits of microsegmentation include that it reduces the attack surface, it gives us simplified policy management, enhanced network visibility, and recognized by key organizations. So NIST, it is recognized by NIST in Zero Trust Guidance of August 2020 and NISA, which has in multiple publications since 2020. Our next topic is SDN, Software Defined Networking. SDN is a centralized network management approach enabling control across vendors, applications, and technologies. So it separates network control logic from data forwarding, that is hardware. It enables dynamic configuration, improved performance, and centralized visibility. So we have three SDN layers. First one is the infrastructure layer, also known as the data plane. This layer includes the network devices such as routers, switches, and data forwarding processes. The control layer basically determines traffic flow based on the infrastructure status and application needs. And the application layer basically are the network services and utilities that define network requirements. So some traffic terminologies that are used in SDN, north-south traffic is basically the traffic that flow between external network, that is internet, and internal network. So the north traffic is basically the external or the internet traffic, and south is your internal network traffic. East-west traffic basically flows within a data center or internal network. This is the traffic inside your own data center or network. It does not leave your organization. SDN advantages include that it gives us centralized control and simplified management, rapid adaptation to threats and network changes, and it gives us vendor independent flexibility. What are some risks of SDN? So misconfiguration of SDN can cause unintended traffic flows, lack of universal standard. There is a lack of universal standard in SDN, although OpenFlow is a key open standard. So What is software defined security or SDS? So software managed policy driven approach to security. It integrates with software defined environments like SDN and enables automated and dynamic security control implementation. Key components of SDS include network segmentation, intrusion detection and prevention, user device identification, and application control. Benefits of SDS includes adaptable and scalable security, centralized policy enforcement, and better suited for virtualized and dynamic infrastructure. So our next topic is SD-WAN or software defined wide area network. So some key characteristics of SD-WAN includes that it has multiple connection support. So it works with various WAN types like Internet, MPLS, or LTE. So for example, if you have multiple carriers or multiple connection coming inside your organization, SD-WAN supports these multiple connection and can act as a load balancer between these different carriers. Dynamic path selection, so it optimizes and share load across available WAN connections such as these. It gives a simplified management. It provides a centralized and user-friendly interface for configuration. And it has the feature of integrated security, so it supports VPN and third-party services for secure communication. So there was some issue with the slide sequence. This should be the first one, but let's go through it now. So it is the extension, SD-WAN is the extension of SDN principle to WAN environment. It enables centralized software-based control over WAN connectivity and management, and it is commonly used to connect data center, branch offices, and cloud service providers or CSP. What is Virtual Extensible Local Area Network or VXLAN, which is a feature or terminology that is used inside SDN and software defined data center. So VXLAN is a network virtualization technology that extends traditional VLAN capabilities. It uses encapsulation to wrap layer 2 Ethernet frames within a layer 4 UDP datagrams. So it enables large scale network segmentation for cloud and multi-tenant environments. Key points in VXLAN include that it is designed to overcome VLAN scalability limits. So it supports up to 16 million VXLANs per domain, while V has the limitation of 4094 VLANs numbers. So it is ideal for large data centers and public cloud providers, and it provides flexible isolation and traffic management across virtual networks. Now coming over to wireless networks. So wireless networks remove the dependency of physical cabling and enable flexible and scalable connectivity. Wireless networks are widely used in homes, enterprises, and Internet of Things environments. The growing Internet of Things demands drives continued wireless expansion. Some security consideration in wireless networks include that wireless network face same risk as wired network plus unique vulnerabilities. So default configuration often insecure, for example, default credentials like admin and password. So the Wi-Fi router also has the main vulnerability or security challenge that when used with the default credential or default configuration, these configurations are insecure. Unchanged default or lack of MFA multi-factor authentication creates major security risk. It is susceptible to man-in-the-middle attacks, eavesdropping, and packet sniffing via electromagnetic signals. So wireless distributed denial of attacks are increasing. Internet of Things devices use the bots in massive botnets. So data emanations from moving electrons can be intercepted and reconstructed by attackers. And modern attacks go beyond war driving. They involve discrete Wi-Fi and cellular surveillance tools. So key defense principles in wireless network include to understand wireless standards and protocols such as Wi-Fi and Bluetooth, implement secure configuration and authentication for wireless access points, to conduct radio frequency mapping and monitoring to detect rogue and malicious activity, and apply defense in-depth strategies for Internet of Things and wireless infrastructure. Wi-Fi overview. So Wi-Fi stands for wireless fidelity and it is governed by IEEE 802.11 standards. So each amendment in Wi-Fi improves the speed, frequency use, and efficiency. 802.11x refers collectively to all Wi-Fi version. Not this, it is not the same as 802.1x, which is port-based security or authentication. In April 2020, FCC decided an open 6 GHz band leading to Wi-Fi 6E, which reduces signal interference. So these are the different Wi-Fi standards, 802.11 standards. You people can pause the video and watch these. So we have the standard name, the frequency used by that standard. As we can see, some standard uses both 2.4 and 5 gigahertz. Their speed, we can see their speed is gradually increasing. The test is the 6 gigahertz and their common name. Wi-Fi authentication and encryption. So authentication methods include open system authentication or OSA, which is no real authentication or encryption, and any compatible device can connect if it is within the range of the Wi-Fi signal. Shared key authentication or SKA, which requires authentication via a shared key. It uses web or wired equivalence privacy, WPA, WPA2, and WPA3 for encryption. Evolution of the Wi-Fi security. So first Wi-Fi security standard were wired equivalent privacy or web, which used RC4 stream cipher and static keys. So these are operated at the data link and physical layers, and it is now vulnerable and can be cracked in a matter of minutes. So it is no longer secure and must not be used. Next is the Wi-Fi protected access or WPA. So it was an interim replacement for web, and it uses LEAP and TKIP for dynamic per packet keys of 1 to 8 bits. It introduces message integrity check instead of CRC, and it is vulnerable to brute force and replay attacks, and such as used in the tools code WPATTY and GPU crackers. Next is the WPA2 or IEEE 802.11i. So this one replaces WPA and uses AES, which is Advanced Encryption Standard as per FIPS 140-2 standard and TCMP. So it has two modes, WPA2 personal, which is password based, and WPA2 enterprises, the enterprise which uses A02.1x network access control server for user authentication. And again, it is vulnerable to pre-shared key theft and man-in-the-middle attacks, which were discovered in 20. The latest standards is WPA3, which was released in 2018. Is mandatory for new devices as of July 2020. It gives us 1 and 2-bit encryption and individualized encryption per user. It mitigates weak passwords and simplifies setup for devices without screens, and it is recommended standard for modern networks. IEEE 802.1x or port-based network access control. So 802.1x is a port-based network access control or NAC standard that provides authentication before granting access to the network. Its purpose is to ensure that only authorized clients can connect to network resources commonly used in enterprise Wi-Fi. And this is how it works. So it uses three roles. First one is the supplicant, which is the client device requesting access. Next is the authenticator, which is typically a network switch or wireless access point. And last one is the authentication server, which is often a Radius or TechX Plus server verifying the credential. So integration, IEEE 802.1x supports EAP, which is Extensible Authentication Protocol for various authentication methods like certificates, smart cards, tokens, and biometrics. And the use case is that it is commonly used in WPA2 Enterprise and WPA3 Enterprise for secure enterprise Wi-Fi authentication. What is Extensible Authentication Protocol or EAP? So it is a framework for authentication and not a single method, and it enables compatibility with various authentication technology. Over 40 technologies are supported. Common EAP methods include EAP TLS, which uses digital certificates for strong security, EAP TTLS, which is which tunnels authentication data, EAP SIM or EAP AKA, which is used for mobile devices. LEAP is a Cisco proprietary protocol, but now it is insecure. PEEP encapsulates EAP within TLS. So note, EAP itself does not guarantee security. For example, EAP MD5 and LEAP are vulnerable. When used with some secure protocol like TTLS or TLS, it then ensures the security. Next one is the PEEP or protected EAP, which uses a TLS tunnel to protect authentication data, and it adds encryption to EAP communications that are otherwise unencrypted, and it is common in WPA2 enterprise environments. Another one is the LEAP, which is lightweight EAP, and it is a Cisco proprietary EAP method designed to improve TKIP or web security. It is vulnerable to password cracking, for example, a sleep attack tool. It is deprecated and used. So LEAP is deprecated and should not be used. Instead, we should use EAP TLS. So this is the tool that can be used to crack the passwords in LEAP, the sleep attack tool. Temporal Key Integrity Protocol or TKIP, it is designed as a temporary replacement for WAP under WPA and uses key mixing sequence counters to prevent replay and a message integrity check. So this one is also now obsolete and is replaced by CCMP/AES Advanced Standard. Counter mode with cipher block chaining message authentication code protocol or CCMP. CCMP uses AES 1 to 8-bit encryption, and it is standard for WPA2 and WPA3 wireless security defined in 802.11i. It is the preferred protocol, so no successful attack against AES has taken place up to date. So how to secure wireless access points? Number one is to conduct the site survey. Site survey is conducted before deployment to to assess existing wireless signals and plan optimal web or wireless access point placement. So this helps detect rogue access points and unauthorized devices connected to the network. It is also used to optimize coverage, reduce dead zone, and prevent overspill into public areas. So the tools that can be used for site survey are wireless scanners or wireless intrusion detection system, WIDS, and the purpose of site survey is to identify, document, and secure authorized wireless access points while minimizing interference and unauthorized coverage. Number two is wireless access placement. So best practices include to use central location for better coverage, avoid walls, metal surfaces, and electrical equipment which causes interference, position antennas correctly. So the omnidirectional antennas are vertical for all-round coverage and directional antennas are pointed towards the intended area only. So tune the signal strength to reduce leakage beyond the intended areas. Number three is the antenna types. As we study, the omnidirectional antenna radiates equally in all directions and is common for office and home Wi-Fi. Directional antenna focuses the signal in one direction and is used for long range or point-to-point links. So be careful with directional antennas because they can extend signal too far, creating potential attack exposure beyond the required range. Number four is the wireless channel. So Wi-Fi uses frequency subdivisions called channels. For example, 11 in US, 13 in EU, 17 in Japan. So channels are chosen to avoid interference and not for security. Channel selection has no impact on preventing spoofing or jamming. So number five is infrastructure versus ad hoc mode inside wireless access point. So infrastructure mode is recommended, which is where we have centralized wireless access point and they manage the clients. Easier to secure and control. We have the variants including the standalone, wired extension, enterprise extended, and free. While the ad hoc mode include devices that connect directly to each other, it is less secure and lacks centralized control. Number six is the service set identifier or SSID. So it is the network name identifying the wireless lane. And the types of SSID include eSSID, which is used in infrastructure mode, and BSSID, which is used in ARC mode, and it uses access points MAC address. Security practices while using the SSID names are to change the default SSID names, which are the vendor defaults, and they are public and known. And to disable the SSID broadcast, to hide the network, which is a partial security, and combine SSID hiding with WPA3 encryption for stronger protection. Number seven is the captive portal. So captive portals are common in public Wi-Fi, cafes, airports, and hotels. So these captive portals redirect users to log in or terms page before granting access. Captive portals can include credentials, requirement payment, or consent forms, legal policies such as privacy and acceptable use policies. And if compromised, a captive portal can inject malware or scripts, so it must be regularly scanned and monitored. Number eight is MAC filtering. So MAC filtering restricts access to approved devices, MAC addresses only. Limitations include they are hard to manage and scale, and they are vulnerable to MAC address spoofing. Some access points include anti-spoofing detection features for added protection. So now coming over to some wireless attacks, and first one is the jamming. The signal jamming is overwhelming a wireless access point with interference, so legitimate traffic fails. Goal is to disrupt or deny service or carry out the DOS attack. So it is illegal in most regions, but cheap jammers are available online. Number two is war driving, which is actively searching for Wi-Fi network, usually from a moving vehicle using scanning tools. Process of war driving is that it detects wireless signals, capture packets, identify hidden IDs, IP addresses, makes an authentication protocol, and attempts to crack the Wi-Fi via tools like AirCrack or AirNot. So our next wireless attack type is war droning, which is a modern variant of war driving using drones to scan and attack wireless networks remotely. What are some motivation and data sharing attacks? So the intent is often to get free internet or collect data for later attacks. Data sharing is that attackers publish Wi-Fi maps with GPS data on sites like Wiggle or OpenBMap or Gemina or Geomina. So, what are some legalities and ethical perspective regarding the war droning, war driving? So, legality is that it is not explicitly illegal in most countries, while ethically it is controversial similarly to mapping public data but may expose hidden or private wireless access points. Li-Fi or light fidelity, so it is a wireless communication using visible infrared or ultraviolet light instead of radio waves, and it has the security benefits that light cannot pass through walls, so it limits the signal exposure and improves confidentiality. So the Wi-Fi signal can pass through your building wall and can be captured by someone beyond your organization or beyond your building boundaries. Li-Fi has the benefit that it cannot pass through your building walls. So it is 100 times faster than the current Wi-Fi. So it is very fast and speedy. And the limitation is that it requires line of sight and cannot transmit through physical barriers such as walls. So its status is that it is an emerging technology with potential to replace Wi-Fi in the future. Bluetooth is the short-range point-to-point wireless communication standard, and it has a range of approximately 30 foot and up to 300 foot industrial Bluetooth usage. Its advantages are that it does not require any base station for operation. It has low power consumption and ideal for mobile and Internet of Things devices. Disadvantages include that its speed is slow, it is slower than Wi-Fi. It interferes with the 2.4 gigahertz Wi-Fi frequency. It has weak encryption and is vulnerable to attacks, for example, bluejacking to snarfing. So the personal area networks or PANs are non-routable and often unmonitored by corporate security tools. Zigbee is the low cost and low power, low bandwidth wireless standard based on IEEE 802.15.4. Its uses include the Internet of Things applications, home automation, medical sensors, industrial control, and smart energy devices. The security features of Zigbee include the access control list or ACLs, frame counters, and 1 to 8-bit AES. Weakness of Zigbee is that it is still vulnerable to Internet of Things based exploits, for example, smart light bulb attacks. Cellular network. So definition of cellular network is that the wireless communication system divided into geographic cells, each with a base station that is cell side acting as a fixed transceiver. And it operates through mobile devices that connect via specific radio frequencies to cell sites or cell towers, enabling communication and internet access. It has multiple generations and they are labeled by development phases, for example, 3G, 4G, and 5G, and not by frequency or power. So, GR for generation, third generation, fourth, and fifth generation. So, some generations of the cellular networks and their timeline and features. So, the 3G was from 2002 to 2005, and features include graphics and formatted text messages, and it supported packet switch data and has the speed of 2 Mbps. 4G was from 2010 up to present, and it has full unified messaging, and it supported native IPv6 and has a greater speed of 1 gigabit per second. 5G was from 2018 up till now. It has ultra high speed, low latency, and Internet of Things integration. Again, it has the native IPv6 support and has the speed of 20 gigabit per second. 6G is expected to be released in 2030. It will be AI-driven networks, holographic communication, and seamless global coverage. It will have the native IPv6 support and AI-optimized protocol, and as it will have the projected speed of 1 terabit per second. So some security consideration of the cellular network include expanded use. So modern smartphone handle application, images, videos, and sensitive data, which increases the exposure. So cellular networks are not inherently secure. So cellular transmissions can be intercepted or spoofed by attackers. So common attacks include rogue base station, IMSI catchers, stingrays, which are used for man-in-the-middle attacks and traffic capture. The impact on organization include BYOD or bring your own devices policies must address the encryption of mobile traffic, application and data management, and network segmentation and monitoring. Our next topic is CDNs or content distribution network. So a CDN or content distribution or delivery network is a geographically distributed system of servers, proxies, and data centers designed to deliver content efficiently to users. The key objectives of CDNs include a low latency, so they deliver content from the nearest server to the user. They have the higher performance, so faster load times for multimedia and web applications, high availability, content remains accessible even if one node goes offline. Advantages include improved performance, so CDN reduces delay by serving data closer to users. It has a greater availability redundancy. The multiple hosting nodes prevent single point of failure. Security and application compliance consideration of CDN include number one is confidentiality risk. So content spread across many servers may increase exposure, and regulatory impact is that data may cross international borders and must comply with data protection license laws in each jurisdiction. So legal compliance include legal compliance is to protect licensed content and ensure lawful content distribution. Common CDN providers include Akamai, Cloudflare, Azure CDN, Amazon CloudFront, Verizon, and Level 3 applications. So what are some secure network components? So security professional must understand how to securely operate and maintain network hardware and related components such as routers, switches, firewalls, and endpoints. So secure operation of network hardware, some secure network components such as standards, policy, and procedures. So they establish secure configuration baselines, management policies, and repeatable operational procedures. Training is admins must receive initial and periodic security training before gaining device access. Change management is that all configuration and page changes must be documented and approved through a formal process. Redundant power, so ensure power redundancy through UPS or dual supply for high availability network infrastructure. Monitoring is to continuously monitor network devices for failures, anomalies, and security events. Warranty and support, so maintain active vendor warranties and access to technical support for troubleshooting and replacement. So key networking terms include data collision, which occurs when two systems transmits data simultaneously, corrupting one or both transmissions. Broadcast domain are logical group of devices that receive broadcast at layer 2, that is data link layer. Collision domain is devices sharing the same transmission scheme where collision can occur. So domain separations or collision domains are separated by layer 2 or data link or higher devices such as switches. Broadcast domains are separated by layer 3 network or higher devices such as routers. So dividing domains improves network efficiency and security. Firewalls are used to control traffic between network segments and enforce security boundaries. So they can be hardware based, software based, or hybrid devices. So every packet entering or leaving the network is inspected and filtered based on predefined rules. Core functions of firewall include traffic filtering, which is blocking or allowing packets based on IP address, ports, and protocols. Boundary protection is separation of internal network from external or less trusted networks. Logging and auditing records activity for incident response, forensics, and performance review. Fail behaviors is should fail closed. The devices or system should fail closed, blocking all traffic if it stops functioning properly. So firewall logs are key events to monitor, reboot. Key events to monitor through firewall logs include these, that is reboots or restart of the firewall, failure to start or system crash, configuration file changes, system or rule error during operation, port scans or access probes, and failed login attempts. Configuration and management. So firewall must be manually configured so they don't provide protection automatically. Rules are defined in access control lists specifying the authorized ports and protocols, permitted IP addresses or URLs, and allowed direction, that is inbound, outbound, or both direction. Firewalls require ongoing patching and upgrades, controlled administrative access, and periodic rule review to reduce human error and misconfiguration. The limitation of firewall include that firewall do not perform authentication. They cannot protect against internal, that is behind the wall threats. So relying on a single firewall creates a single point of failure. So they must be part of a layered security or defense in depth approach or strategy. What are some types of firewalls? So there are four primary firewall types which are characterized by the OSI layer where they operate. Additional modern variation include next generation multi-home firewall. So number one type of firewall is static packet filtering firewall, which operates at the OSI layer 3 or network layer. It is also called as the screening router. It inspects each packet individually based on predefined rules. So its pros are that it is fast and simple, and cons include no authentication, vulnerable to spoofing. Use case includes basic perimeter defense of the organization. Number two is the application level firewall, which operates at the OSI layer 7 or application layer. It is also called as proxy firewall. An application layer firewall deeply inspects traffic to identify and control specific application data. Pros include high-level filtering and it blocks malicious contents. Cons include slower due to deep inspection. And use cases include that it protects end user from external network threats. Number three is stateful inspection firewall, which operates at the layer 3 and layer 4 or network and transport layer of the OSI model. And it tracks connection states, for example, three-way handshake of the TCP and apply rules based on the context. Pros include smart filtering, good balance between security and speed. Cons include that they are more complex to configure and they use more resources. Use cases include enterprise perimeter defense. Number four is the circuit level firewall, which operates at the OSI layer 5 or session layer, and it verifies TCP handshake but does not inspect traffic. Pros include it is efficient and hides internal network details. Cons include limited inspection capability. Use cases include session validation and network address translation environments. Number five is the next generation firewall or NG firewall, which operates at the multiple layers of the OSI, and it combines traditional firewall features with the intrusion detection and prevention system, deep packet inspection, application awareness. Pros include comprehensive protection and detecting the modern threats. Cons are it is costly and resource intensive. And use cases include modern enterprise networks requiring advanced threat prevention. So, what are the basin host or screened host? So, a basin host is a hardened special purpose computer placed in a DMZ or demilitarized zone behind a core router. It acts as a protective gateway between a private network and an untrusted network like the internet. Key features include it is also known as the screen host or jump box, and its purpose is that it acts as a proxy, allowing external users controlled access without exposing internal system. It hides internal network identities and limits direct connections from outside. Application include that it runs only minimal and essential services, for example, proxy server, SSH gateway to reduce attack surface. So security role of basin or screen host include that it serves as the first line of defense for inbound connection. It insulates internal systems, so if compromised, it limits attacker movement within the network, and it is commonly used for administrative access or controlled external communication. So firewall deployment architecture, first one is the screen subnet architecture. So a screen subnet combines basin host to separate public and private network segments. The public segment is the segment where which hosts accessible services, for example, web or proxy servers. Private segment are the internal system protected from the public access. So this improves both security and network performance. Multi-firewall deployment is relying on a single firewall is not recommended. So multiple firewalls are deployed at different network tiers to increase protection between subnets and external networks and to provide defense in depth and redundancy. So modern cloud and virtual deployments include cloud firewall, for example, AWS security groups. So virtual as stateful firewall for cloud instances, for example, for Amazon EC2. And these cloud firewall control inbound and outbound traffic within a virtual private cloud or VPC. Firewall as a service is the cloud delivered firewall managed by the cloud service provider. Benefits include automatic updates, scalability, and centralized management. It requires strong trust and compliance assurance with CSP. Software defined networking, so it is flexible and programmable networking that can dynamically adjust firewall rules. Advantages include easier automation and policy control, and challenges are in complexity, maintaining consistent security policies. So, secure network components continuing with the repeaters, concentrators, and amplifiers. So all these components operate at layer 1 or physical layer, and their purpose is to extend signal distance and strengthen weak signals. So they connect system within the same collision and broadcast domain. Hubs are also layer 1 devices known as multi-port repeaters. So they function their function is that they repeat the inbound traffic to all the port. The drawback is that no traffic filtering or segmentation is carried out by the hub. So this is a security risk. So in modern network, it is replaced by switches due to poor security and efficiency. Bridges, so bridges operate at layer 2 or data link layer, so they forward traffic based on MAC addresses. So they connect network using the same protocol but different cabling or speeds. So systems share a broadcast domain but are in different collision domain. So use spanning tree algorithm to prevent broadcast loops. Switches operate primarily at layer 2 but some at layer 3, also known as layer 3 switches, which has the routing feature. Function of switches include that they forward traffic only to intended recipients. They create separate collision domain per port, and they support VLANs for broadcast domain segmentation. The benefits of switches include that they improve throughput and security by isolating traffic through VLANs. Routers operate at layer 3 or network layer, so they connect different networks and route packets based on IP addresses. So they either use static or dynamic routing, for example, BGP, OSPF, and RIP. So each side of a router has different broadcast and region domain. So dynamic plus static routing together gives us the best redundancy. Gateways operate at layer 7 or application layer and sometimes at layer 6 or presentation layer. Their function is to connect networks using different protocol, that is protocol translation, also called as protocol translators. So common type of gateways include data, mail, application, secure, and internet gateways. So they bridge between on-premises and cloud networks. Proxies is a type of gateway working as a mediator, filter, or a cache. So it operates within the same protocol, unlike gateways, and it is commonly used for net or network address translation. They helps anonymize traffic and protect internal network structure, and they uses SOC v5 protocol, which supports authentication. Lane extenders are multi-layer switches used to extend lane segments beyond normal limits. They may act as WAN switch, router, repeater, or amplifier, and they are useful for expanding lane coverage while maintaining performance. So wireless access points or WAPs operates at layer 2 or data link layer, and they allow wireless devices such as laptop, phone, or tablets to connect to a wired or wireless network. The wireless router role, they act as both a router and a WAP in integrated networks and determine the best pathway and destination for packets. Frequency bands used by WAPs include 2.4 GHz and 5 GHz, dual and multi-band operation. Typical speeds of WAPs include up to 300 Mbps on 2.4 GHz and up to 450 Mbps on 5 GHz. So they enable portable endpoints to access network resources wirelessly. Now coming over to transmission media, so security of transmission media includes protecting physical network media in addition to devices and software. So media connects network nodes across lanes and WANs. So local area network or LAN technology include Ethernet IEEE 802.3, which is most common LAN technology used at layer 1 and layer 2, and it uses frame as protocol data unit and support full duplex communication with twisted pair cabling. Topologies include star and bus, and types include fast Ethernet that works at 100 Mbps and gigabit Ethernet that works at 1 gigabit per second, while 10 gigabit Ethernet works at 10 gigabit per second. So 8 bit is equal to 1 byte, and 80 Mbps is basically 10 megabit per megabyte per second. So 80 Mbps is equal to 10 megabyte per second when you divide 80 by 8, because 8 bits are equal to 1 byte. So we already studied the Wi-Fi standard. Now coming over to the different networking cabling types. So the wireless LAN or Wi-Fi has, as we already studied, two modes: infrastructure mode, where devices connect via wireless access points to wired network, while ad hoc mode is the peer-to-peer device communication. It can be between the wireless access points and must use encryption due to open sonic network. These are different networking cabling types, their speeds, distance they support, electromagnetic interference susceptibility, and cost. So these were the older standards, and these are the, you can say, the latest standard. And as we can see, their speeds are increasing, as well as the, you can say, distance. So for the most modern Cat 6, Cat 7, Cat 5 cable, the maximum distance is up to 100 meter, and susceptibility is medium or high, and cost is somewhat medium or high. Optical fiber is different from all these. It has a very high speed, high distance, has no susceptibility to electromagnetic interference. Cost is very high as compared to all other cable types. So the cable types include the coaxial cable, which is copper core, which has copper core with shielding, and it resists electromagnetic interference and supports longer distances. So this one is now largely replaced by a twisted pair due to cost and flexibility. So the next cable type is the twisted pair UTP, which is unshielded twisted pair, or STP shielded twisted pair. So these are four twisted wire pairs which reduces crosstalk and electromagnetic interference. So STP, or shielded twisted pair, is the metal foil shielding, and UTP has no shielding, which is commonly used for Ethernet. Fiber optic cable uses light pulses, not electricity, and it is tapping and interference. It has high speed, long range, but expensive and difficult to install. So additional consideration of transmission media include 543 rule, that is tree topology. This topology we can have maximum, we should have recommended to have 5 segments, 4 repeaters, and 3 populated segments with devices. This arrangement prevents signal attenuation and maintains reliability. So now coming over to network topology. So topology is the structure and arrangement of network nodes and connection. Physical topology is the actual layout of cable and devices, while logical topology is the how data flows within the network. So there are 4 main topology types, including ring, bus, star, and mesh. So our first topology type is the ring topology. In this topology, devices form a closed circular path and data travels in one direction in the form of a, you can say, a circle or a ring. A token is passed between nodes. Only the node with the token can send data. So there are nodes. These are, let's suppose, nodes, and there is a token that is passed between nodes, and the node that has the token can send the data. Failure of one node can break the entire network. Since this whole network is in the form of circle, if one node fails, it means the entire network fails. It is efficient for small networks because no central server or switch is needed. Dual ring design prevents single point of failure. So we have dual ring design. If one ring fails, the nodes can still communicate through the secondary ring. Pros of this topology is that it is simple, it has fast data transfer in small setups. Con is that it is not scalable. One node failure disrupts the whole ring or the whole network. Next is the bus topology, where all nodes share a single backbone known as the bus. Data is sent to all devices and only the intended recipient accepts it. It has two types. First one is the linear bus, which has a single backbone. The form of this, such as this is the bus or the backbone. Here we have the node that are connected to this bus or backbone. Then the tree bus, which is the backbone with branch segment. For example, we can have a tree segment in the form of a this, where we have further nodes connected to other segments as well. So it requires terminator at both ends. Terminator means that if it is the bus, we require terminator over here and require terminator over here. Pros is that it is low cost and easy to add devices to this bus. You can easily add devices. And cons is that it has collision since all the devices share the single bus, single media. There are chances of data collision, and single failure breaks down the whole network. So if this single cable breaks, the whole network, you can say, is broken down. Next is the star topology, where every device connects to a central hub or a switch. Failure of one link does not affect others, which gives us good resiliency. It is common in modern Ethernet networks and can logically represent ring or bus using a hub or MAU. Pros of this topology is that it is easy to troubleshoot and isolate faults. Is because we have the central switch, all devices are connected to this switch. So if there is issue, let's suppose with one device, let's suppose there is issue with this device, we can isolate the issue. We can either see that issue is with the cable or issue is with this port. So issue can easily be isolated. Con is that the hub switch is a single point of failure. So if this switch fails, it means your whole network is down. Next is the mesh topology, where devices are interconnected via multiple redundant links. Full mesh is where every device connects to every other device. For example, if we have three devices, simple network, it means this one is connected to this is to this, to this. If we have four, it means this must be connected to each devices. So it gets complex when the devices number increases, because every device must be directly connected to every other devices. In partial mesh, only some devices are interconnected. So for example, if we had partial mesh, you can this let go of this link. So these devices are still connected to each other. It offers maximum reliability but high cost and complexity. As we can see, when the devices increases, the complexity and cost of connecting the device to each other device also increases. Pros is that it is very fault tolerant and resilient. It is fault tolerant because if one link breaks, the devices can still connect to each other through other redundant links. Cons is that it is very expensive because we have very lots of link. Each device is connected to each other. It is complex to manage due to lots of connectivity and redundant link, and also resource heavy. So a comparison table of all the topologies. So the ring is the circular loop. Resiliency is low to medium. Scalability is low. Cost is low. Bus topology is in the form of a single backbone. Resiliency is low because if the main bus breaks, the whole network breaks. Scalability is also low. And cost is also low because you just require a single bus. Star is the structure, it is in the form of a central hub and switch. Resiliency is medium to high, scalability is high, and cost is medium. Mesh is fully interconnected, resiliency is very high, scalability is low to medium, and cost is very high. So if people know the modern network, all network almost uses the star topology because we no longer uses the ring, bus, or mesh topology. We uses the switches, routers to connect the network. Our next topic is network access control or NAC. So NAC enforces security policies across all users and devices before granting or maintaining network access. Goals of network access control is to mitigate non-zero day attacks, to authenticate and authorize network connection, to apply role-based access after authentication, to encrypt wired and wireless traffic using 802.1x, that is EAP, TLS, PEEP, and MS-CHAP, to enforce page and compliance requirements, to control access by device type and user role, and to enable identity-based access management. So next topic is the endpoint security. So endpoint is the protection of all endpoint devices, for example, desktops, laptops, servers, mobile, Internet of Things, industrial control system, and robots from cyber threats through monitoring, detection, and response. So why it is matter and why it matters? So this prevents infected or non-compliant devices from endangering the network. It complements NAC or network access control, UEBA for stronger and layered security. And it is critical as attackers increasingly steal valid credentials or exploit remote access. UEBA is user and behavior analytics. So key concepts in endpoint security include the EDR, which is endpoint detection and response. So this continuously monitors endpoint and network events. EDR detects, investigates, and responds to suspicious activities. Defense in depth, so it integrates endpoint protection with firewalls, intrusion detection and prevention system and proxies. Zero trust integration means that you need to never trust any device and always verify every endpoint and user. If even the endpoint is your internal, trusted, or local private device. Zero trust means that you should always, every time, verify the identity of each and every device. The endpoint controls include local host firewall, advanced threat protection, multi-factor authentication, client-based IDS and IPS, and continuous auditing. Mobile security, so some risks to the mobile security are loss and theft. So due to small size and high data capacity make mobile devices easy to lose and a major data loss risk. Attack platforms, so infected or botnet controlled mobiles can launch attacks. Personal ownership, so bring BYOD increases exposure to untrusted or jailbroken devices. Best practices include minimum data retention, so keep only necessary data and delete old information. Authentication is to use strong passwords, biometrics, and MFA or multi-factor authentication. Encryption is to enable full disk encryption, for example, using AES 256. Integrity checking is to verify devices' status that they are not rooted or jailbroken before granting the network access. Management and policies regarding the mobile devices security. So MDM is the mobile device management, which gives us the centralized control, enforcement of security policies, and remotely wiping or deleting the data on mobile devices. Containerization is to isolate corporate data in encrypted and managed containers. BYOD and COPE policy. So BYOD is bring your own device, which is employee-owned, organization-controlled via secure containers. And COPE is company-owned, but personally enabled devices. So according to NIST SP 80124, guidance on secure mobile devices management and authentication. So this publication gives us guidance on secure mobile device management and authentication. Remote wipe is that authorized deletion of data from lost or stolen devices. Secure communication channels. First one is the voice. So voice security concerns include voice system, which may be digital or VoIP, that is voice or IP, can be intercepted, altered, or hijacked. Key security goals include authentication to prevent unauthorized interception or impersonation, integrity to protect message and media from tampering, confidentiality, encrypt voice data in transit. So note end-to-end encryption is limited. Some decryption may occur for law enforcement compliance. Number two is PBX and POTS security. So PBX is the private branch exchange and POTS is plain old telephone service. So PBX are private branch exchange, which is enterprise internal phone system. Vulnerabilities in this system include default configurations, open ports, and codes. A risk that is posed by this system is the toll fraud, which is unauthorized premium cost to this system. Controls include to change the default configuration, monitor bills, train users, and use call monitoring tools. POTS are plain old telephone services or analog lines which are vulnerable to tapping and eavesdropping. Controls include physical security, network segregation, and monitoring of legacy systems. Number three is the VoIP security. So VoIP is voice or IP network using TCP IP suite. Threats to this VoIP include caller ID spoofing through phishing, that is voice phishing, and spit, which is spam or internet telephony. Denial of service attacks on VoIP servers or phones, man-in-the-middle attacks via spoofed endpoints, and unencrypted VoIP traffic can be decoded. Mitigation include to encrypt VoIP streams, for example, SRTP and TLS, and to strengthen authentication and access controls and harden VoIP servers and monitor for anomalies. Next is the multimedia collaboration. So remote meeting security. So multimedia collaboration include video conferencing, chat, voice over IP, file sharing, and digital whiteboards. Security risks arise from remote access and lack of physical presence. Key controls include that users should require the authentication. For example, pre-registration before entering the conference and using unique password. Use encryption for voice, video, and data transmission, and limit screen sharing and meeting access to verified users. Next is the Zoom bombing. So Zoom bombing is the unauthorized intrusion into video conferences, was common during COVID-19. Attackers may insert offensive or malicious content. Prevention include to enable waiting rooms and meeting passwords and restrict screen sharing and guest access, and to update the conferencing software regularly. Instant messaging security. So instant messaging allows real-time text, file transfer, and screen sharing, often through open ports, for example, port 80 or 443. Vulnerabilities include weak or no authentication, which can lead to spoofing. Lack of encryption can lead to packet sniffing attack, and file sharing can increase the risk of malware risk. So they are susceptible to social engineering as well as the spam, which is uh, internet. Instant messaging spam. So controls include to enforce authentication, encrypt instant messaging traffic, and use endpoint protection. Number four is the email security fundamentals. So email uses SMTP, POP3, and IMAP, which is critical for communication but vulnerable. Common threats include open relays, spam, phishing, spoofing, and controls include strong authentication and relay restriction, spam and malware filtering, encryption such as TLS, SMIME, and pretty good privacy or PGP, and user awareness training. So email security standards and protocol summary. So we have these different standard and protocol that can be used in security. These are their purpose, and these are the key features are the encryption cryptographic algorithm that are used by all these standards. Remote access. So how to remote secure the remote access of systems. So remote access enables employees to connect from home, remote offices, or cloud platform. It is driven by globalization, cloud computing, and work from anywhere trends. Remote access paths include internet connection, which may be with or without VPN, and it may be thin client or terminal server access. So remote access techniques include excuse me, the first one is the server specific access, which is access to a single application like OA or time tracking. And security concern with this one is that it has limited scope and lower risk. Number second technique is the remote control, which is full desktop control, for example, via RDP, which is Microsoft Remote Desktop Protocol, or through TeamViewer. And security concern may be the brute force or credential theft. Next is the screen scraping, which copies displayed data between application. And security concern include the data leakage or unauthorized access. So remote access security risks include remote access basically expands attack surface beyond physical boundaries, and common concerns include remote system may have weak physical security, infrequent updates, so we may have unpatched vulnerabilities, infected endpoints may introduce malware to the system that is accessing the remote system. So harder IT support and troubleshooting. Troubleshooting the remote system and giving the support is hard. So Wi-Fi use is considered remote access even inside the corporate premises. So security control for remote access include to implement strong or multi-factor authentication, limit access to essential user and devices, to encrypt communication using VPN, SSL, TLS, SSH, or IPSec, and combine it with endpoint protection and user and entity behavior analytics. So remember, VPN is not total security, endpoint hygiene still matters. For example, VPN is mainly for the transit packet protection. For example, if this is your client, this is your server, so your client is in one country, server is in another country, you have the internet between. So VPN is used to encrypt the traffic between them. But you still need to protect this server, you need to enable its firewall, you need to have endpoint detection and response, you need to have anti-malware and antivirus. Similarly, you need to have all the security checking on this client as well. So what are some remote authentication protocols? So these include the PAP, which is basic password based authentication, and it is unencrypted and weak. Next is CHAP, which is challenge response based authentication. and it protects against replay attacks. Next is the EPEEP and LEAP, which are the framework for network authentication. They support multi-factor authentication and certificates. Next is the Radius, which has the centralized authentication server known as Radius, and it is common for VPN and Wi-Fi. Next is the Diameter, which is successor to the Radius, and it adds reliability, and it is used in mobile networks. And last one is the TechX Plus, which separates authentication, authorization, and accounting, and it supports two-factor authentication used in Cisco networks. So our next topic is VPN or virtual private network. So VPN is a secure point-to-point communication tunnel or an untrusted network. For example, the internet. So internet is untrusted because you never know where your packet is passing through, which IP, ISP or internet service provider is sniffing your network. So VPN is therefore important so that your data is encrypted when it goes through the untrusted networks such as the internet. So it uses encryption to protect data, but encryption is not required for it to be considered a VPN. So common uses of VPN include secure communication between remote users and corporate networks, intra-network data protection, site-to-site connections between private networks, secure legacy or risky application, and ensuring confidentiality and integrity, not availability. So VPN ensures mainly confidentiality and integrity. So tunneling concept is that in tunnel we encapsulate the packet inside another protocol to protect them. This creates a logical tunnel across untrusted networks which is visible only to the tunnel endpoints, and it is used to bypass firewalls or proxies when authorized. Advantages of tunneling is that they are secure and routable for non-routable protocols. The risks include that it is hidden from security inspection, so malware can be concealed inside the VPN traffic. It increases the overhead and bandwidth usage, and it is inefficient for broadcast traffic. So some common VPN protocols include PPTP, which is point-to-point tunneling protocol. It works at layer 2 of the OSI layer. Yes, it has the encryption, but weak encryption. It is derived from PPP and it supports CHAP, PAP, EAP, and is vulnerable to man-in-the-middle attacks. Layer 2 tunneling protocol, again, it works at layer 2. It does not give encryption by itself, but it is often, for encryption, it is combined with IPSec, and with IPSec, it gives both the encryption and authentication. Next is the IPSec, which works at layer 3. It gives encryption and it gives strong encryption. It provides secure data transfer with encryption and integrity. Last one is the SSL/TLS, which works at layer 5 and 6 of the OSI layer. And yes, it gives encryption. And it is mainly used for web-based VPNs and remote access through browser. So keynotes of the VPN include that the PPTP or point-to-point tunneling protocol is legacy and insecure, and it should not be used for sensitive data and environments. So layer 2 tunneling protocol should be used with IPsec for security. So it is common modern combo for secure site-to-site or remote access VPNs. So tunneling increases security but reduces visibility for monitoring tools. Data communication is that data centers and data enters and leaves the network over various communication paths. So common frameworks include frame relay, ATM, MPLS, and virtualized networks. So frame relay is the WAN technology using packet switching at layer 2. It connects LANs to WANs via lease D1 lines. It uses virtual circuits, not dedicated links for efficiency. And it has the confidentiality risk, so you should use VPN encryption over shared circuits. Next is the ATM, which is asynchronous transfer mode. So it is a high-speed layer 2 standard for voice and data. It uses ATM switches for point-to-point connection does not do any routing. It supports quality of service level. CBR is the constant bit rate, VBR is the variable bit rate, ABR is the minimum guaranteed rate, and UBR uses remaining bandwidth. So it is used over SONET/SDH backbone and supports up to 10 gigabit per second speed. Next is the MPLS, multi-protocol label switching, which combines the benefits of ATM and frame relay. It provides high speed and reliable packet switching, supports traffic engineering and quality of service. Virtualized circuits combine hardware and software networking under software control. It is managed centrally. You do not need physical presence. And it enables SDN, software-defined networking, software-defined security, and micro-segmentation for better control and security. So third-party connectivity includes internet service providers, cloud provider partners, and vendors. So always use SLA or service level agreements to define and enforce security expectations. Apply encryption, access control, and continuous monitoring, and ensure compliance with data protection laws, for example, SOC 2 reports. So that's all for this domain. I got through domain very fast due to the sheer and large number of slides, but I will share the slides in the video description so that you can go through at your own pace through the slides. And remember, uh, even if I went through fast through the slides, it is still important that you go through these slides and through this video, because if you are using any book I have the use the CBK reference to prepare the slides. So if you are using the, let's suppose, OSG, going through this will give you an alternative perspective and will add to your knowledge. So please like, subscribe, and share the video, and we'll see you in the next domain.